Now let's talk about distributed computing. This is a key concept in big data, and it stemmed from Yahoo and Google, companies that were trying to index the entire internet and interact with those indexes. And so for this example, because it can be so complex, I'm going to boil it down to kind of the simplest form and talk about our story with Cogsley Services. So Cogsley Services started a new support service. This support services allows customers to actually get help about products just by simply clicking a button in their web browser. They can click a button and be connected to one of our experts available to help them with whatever their needs are. Well, to support this service, what we did is we stood up a data node here. And this data node handles all those requests. It stores the data, it does the machine learning, it processes everything that's happening, and then it seemed to work well. So as our support service grew over a year, we needed to increase the size of our data node to support the additional customers, the transactions, all the machine learning that's happening, everything there. So what the system is now is just it's able to support it, but we have a key problem here. And this is the difference between the traditional approach of scaling up our systems versus scaling out or distributing the load. Here we have a single point of failure. If this data node were to die, the entire system shuts down. And as this has become a mission critical part of Cogsley Services revenue, we really need to make sure that we have a system that will support it no matter what happens. So instead of doing that, what we did is we bought a bunch of little systems, and now we have the load spread across all of our data nodes instead of just one main one. This is the key idea behind distributed computing. So that way, if we had 10,000 nodes in our system supporting it, distributing the load, letting us scale tremendously, and we have a 1% expected failure rate, that means we're always going to have about 100 nodes that are down, that are not working, that are failing. And so we need to design a system that will be able to support expecting certain pieces of it to always be failing or always be not working as optimal as they could be. And this is something that is a key part about why we would use a distributed system versus a traditional system, which is clustered.